Dear learners, welcome to third session of 6th week. In previous session, we have discussed about the key aspect, building block strategies for making manufacturing as a smart, manufacturing as a intelligent. In this journey of learning, now I like to touch upon autonomous. Autonomous is completely different concept as compared to automation. And technologies like robotics and humanoids and generative AI are helping to make the companies autonomous. May not be 100%, but say 50%. 50% their processes are autonomous. So let us begin this journey. I like to start this session with the outcome of one of the panel discussion held in World Economic Forum Davos Summit in the month of February in Switzerland. And the topic of this discussion was keeping up with the smart factories. And there were panelists, a very senior panelist was there from the companies like, from the Siemens, Agilent, and even Deputy Prime Minister of Singapore, Prime Minister office was there. And then, Group CEO and the Managing Director of our Mahindra Group was there. And the host herself was a very seasoned and very experienced person, Tian Wei from China Global Television. I try to capture the outcome of this discussion in 4 slides. On the left hand side, you are seeing that one of the key outcome which is worth reading, I will say, then I will explain you. The new factory is fundamentally modeled in a digital space before it exists or operate in the physical world. This is the ultimate expression of the connected and real-time attributes which we discussed in the previous session. The concept, what is the concept? The factory run on a digital twin that is photorealistic and physics based. This is what has been expressed by Roland Busch of Siemens. This is beyond a simple 3D model. It is living, breathing, virtually replica that behave exactly like the real factory. For example, predicting how fast a robot can move before it starts swinging. So today, before a factory come into existence, there is a good practice to develop a digital twin, to develop the replica of the factory in the digital space and keep updating this replica as the commissioning or the building of the factory progress or machine progress, so that you have a digital replica of a machine or a factory beforehand, before it starts functioning. The health of the factory is reflected in the digital replica. This is one trend which advanced factories, or especially the factories which are coming into existence now, and a good number of vendors like Siemens or Honeywell or ABB are helping companies to build this digital twin along with the building of the factory, along with the commissioning of the factory, along with the design of the factory. And what is the outcome? As you read here, this enables full simulation on optimization of production, R&D, logistics before resources are committed, leading to a dramatic reduction in time to market and manufacturing cost. And this has been proved. A case study was discussed by the representative of Agilent. Agilent is one of the famous company in Europe. And which are the key enablers? Low code platforms. You must be knowing about no code and low code platforms. Software platforms are being used to democratize access to this complex technology. I am sorry that no students, I brought this example little out of way, maybe sometime difficult to understand. I will say you read and read this statement, and I want to know the learner of this course should try to get a good exposure about the latest trends. So on the right hand side, I have tried to depict this phenomena, this latest phenomena of, we call it industrial metaverse. This is different from the metaverse, the actual metaverse, which is based on AR, VR and so many other technologies. But they have given, while the discussion was going on, I have also given the link of this YouTube discussion. It is a 46 minutes discussion. You can go through this. It is a very interesting discussion. And you can see here whatever I have explained over, it is being shown in this picture. Industrial metaverse, digital twin, photorealistic. Is a good terms which you should try to note it. Photorealistic. Photorealistic. What is happening in the plant I am seeing on the picture. What is happening in the machine I am seeing in the picture. That is called photorealistic, physics based. So, and you are able to simulate beforehand what is going to happen. So, any eventuality, and this is a kind of thing is being used in a very complicated technologies like spacecraft, sometimes also in the now in the nuclear power plants, So it is very important that we should know the digital replica of a nuclear power plant, a high risk area. Okay, so I thought I will bring this concept to you, and you would like to further explore this idea. Whosoever is interested in that. The second thing which we already discussed in the previous session, and they all have agreed that the intelligence driven autonomy and proactive control. Intelligence driven autonomy and proactive control, the model moves from being reactive to being entirely proactive and self-optimizing. So today's world, the smart factory has to be self-optimizing. We need not to optimize them. The technology has been deployed in such a manner that it optimizes its function. It optimizes the function. You need not to teach all the time. You need not to give a direction. So this is where the technology is playing the role. And thanks to the technologies like humanoids, humanoids are sometimes having their own thinking based on some algorithms, and deep learning kind of algorithms are there. And they can optimize, they can take action as per the situation in the given situation. This is the definition of high level intelligence. Proactive quality. AI systems are monitoring production parameters like weld temperature, material flow, energy usage. These are the words of these panelists. This is not my words. They start talking. They narrated this. This from their examples. AI systems. I have also shown over here in a picture. Autonomous decision making. AI agents. Today is you must be knowing about the AI agent. You must be hearing that. So far I have not discussed about the AI agent, and I will be discussing the role of AI agent in the next session. AI agent or industrial co-pilots, the industrial co-pilots, the way a pilot, lead the aircraft or fly the aircraft, the AI agents are going to play this sort of role as per these, panelists, high intelligent, highly experienced, these guys, they talk about that AI agent as an industrial pilot interact with the operator while natural language diagnosing and recommending. We will be seeing in this presentation some of the dialogue in the natural language, the generative AI and self-optimization. So these are the new trends, no? These are the new trends, no, in the smart factory arena, the intelligence-driven autonomy and proactive, no, control. The end-to-end boundary-less value chain. We have already discussed about these facts, no, but here, no, they have expressed with the help of some of their own experience, no, the full integration across functions which we discussed in the previous session. Resilient operation. This is a new term, no, and this is the phenomena of Industry 5.0. The resilient operation, the agile and resilient operation. This is the phenomena of Industry 5.0. Thanks to technology, with the help of technology, we are able to develop the resilience in the operation, resilience in our plant operation. So that rapid changeover and mass customization is possible with that. I hope that you understand, and there are some examples one can find by Unilever, which is one of the global lighthouse companies, strong resilience against supply disruption. So Unilever has developed a system which has a resilience kind of phenomena, which has capability, I will say, not the phenomena, strong resilience capabilities. Is there any disruption in the supply chain? Suppose a supplier is not supplying, or there is a shortage of some raw materials, whatever, how you, without completely stopping the operation, the manufacturing, how you create a new situation and a new kind of pattern in your manufacturing, so that the operation keep moving, It should not be completely affected. It will be affected, but not to that extent. So that is what is the strong resilience, and technology is helping over here. Ecosystem collaboration is also one of the important aspects of the smart factories. They collaborate, they integrate with the suppliers, with their bankers, with their partners. So this is also one of the important aspects. Mahindra is doing supplier integrations, and Siemens is having a platform for industrial ecosystem. Unified value chain intelligence, again that is this concept has been discussed in the previous our presentation, that what is the importance of value chain intelligence. So I thought I will bring this example of this great discussion, so that we are on the latest pitch, what is happening in the industry, and we should know about that. And this is something very, very important and eye-opening to all of us, that the augmented and sustainable workforce. I would like to mention over here the success of Industry 4.0 in general, and in particular the success of smart manufacturing will depend upon that how well is our workforce, staff is prepared for this change. So they have shared their vast experience, how these companies, or how they are, in fact in Singapore also, the Deputy Prime Minister shared that what all the steps they have taken to upskill, in upskilling as an investment. I am not going in full detail of this. You can yourself watch this, and you should try to go through this presentation, on this slide of the presentation. And augmentation, not replacement. This is a very important aspect of this session, I will say, that how with the help of humanoids, how with the help of co-pilots, we augment the capability of our workers. So that suppose there is an operator, and he or she need some technical guidance, and he or she is having something called AI co-pilot. So AI co-pilot should be used to guide that person to take the further corrective action. That is the human AI collaboration, and this is where now technology direction is there, that more and more human AI collaboration should be there. It is not like human cannot do that work, but with the help of AI, the precision comes, the speed comes, and sometimes you don't have the knowledge, the worker is not having the knowledge, AI can supplement that knowledge. So this is a very important aspect of augmented and sustainable workforce. So I thought these are some of the things which you as a learner should know what are the latest development. No, I am not going in much detail. In fact, in my deck, no, you will find some examples which has been shared by these panelists. No, please go through these examples. No, how they are using these technologies in their various areas of process control, predictive, workforce empowerment, etc. So now looking into this picture, which is again the representation of the intelligent manufacturing system, which in a different manner, though we have discussed in the previous session the intelligent manufacturing system and processes. So you will see here the 5 layers or 5 blocks. I will say the bottom layer is the connectivity and infrastructure, which we discussed. The second layer is the digital planning and management tools, which we have to establish. A proper digital planning. Planning should not be ad hoc. Planning should not be manual. It should be fortified with the facts, with the data. That is called digital planning and management tools. And then we should have connect production and production, robotics and automation. So if we want to establish intelligent manufacturing system, we have a very good scope of using robotics and automation in the production areas. Especially in the hazardous areas, or those jobs which can be done by the robots, can be easily done or can be as a co-pilot. We will see those examples in a few minutes. Then workers' connectivity and digitalization. The workers are connected with the plant. They are seeing what is happening in the plant. They are seeing on the screen what is happening in the plant. Any mistake they have committed, they can recover that mistake. So this is all intelligence has to be built up, and top of that is the machine intelligence. Machine intelligence is to optimize, augment or automate decision making such as heuristic models, applied AI and generative AI. So the ultimate objective of the intelligent manufacturing system is to develop the machine intelligence. As we have the intelligence as a human being, suppose you are a doctor, you have intelligence to diagnose and then to recommend some medicines. Like that, with the help of this kind of infrastructure, this kind of facilities, machines should develop the intelligence, and that is what is being attempted now in the era. In the industry sector, those who are trying to adopt the intelligent manufacturing systems. Now you are seeing a picture that how the AI systems are changing. Earlier, AI systems used to have this kind of the outcomes. They were outcomes mostly on the data, the reports. And now the AI systems are able to generate the videos, generate the audios. They can take the command in languages, and what I am talking is about the generative AI. Generative AI is a new field, I will say, which started in the industry application some 4 years, 3.5 years back, and now we are seeing the very high impact of generative AI systems in all areas of human life as well as in the industry. So this is a subject of study which I will say that any learners who wants to know that how the AI systems are helping the industry and what is the scope of that should go in deep of this subject. I would like to explore little more in the next session how this LLM systems or generative AI is helping the industry. This is one of the basic picture which how the content is being created by some of the generative AI tools like Perplexity AI or Canva is being, you must be also using, some of you must be using Canva for generating of the excellent visuals and like that, visuals and presentations, I am sure that. So, so here now the focus of these technologies and tools has gone on the generation part, not only optimizing, but they are generating some new content. So what is that behind of that? How it is being done? That is a subject we should try to learn. I am going to share some of the insight in the next session of our this week. Similarly, these AI tools are being used for creation of the videos. You can see in our media industry or in the film industry, sometimes you find that these videos are being created completely by AI tools. So there is a technologies like in video which you can use it. So I thought I'll just give a glimpse of the change in the AI field with the help of generative AI and some advanced tools like agentic AI, and is the subject of key learnings nowadays beyond AI only. So that is what. Now we will spend some time to learn some of the basic functions of robotics in manufacturing. I like to take this definition of robot from Wikipedia. Robot is a machine, especially one programmable by a computer capable of carrying out a complex series of action automatically. This is very important. Tomorrow, if we send the robots on the moon surface, the robot should be able to perform the action which are directed from the ground. And this is what has happened when India's spacecraft has landed on the moon. It was a robot which has done all those operations and carried out the research, collected the lot of the artifacts, and it has brought back to the country. And so robot is a machine, especially one programmed by a computer. This word is very common, but we have to understand the correct meaning of the robot. This definition is a good definition, but there are a lot of enhancement. I am showing in this slide some of the robots, not all. I have taken this slide from one of the article of the McKinsey. So there is a robot which is a standalone, which do only one kind of work. One kind of work is called SCARA. As per the McKinsey, SCARA robots are models like human arms with an elbow, shoulder and wrist. They have 3 axes of X, Y, Z movement and additional axis for movement of the end effect. The setup of the axis allows the robots to extend their arm and to retract it by folding up. The way we do arm twisting or we lift something, these robots are able to do that. Then collaborative robots these are very commonly used nowadays. These all 3 robots, collaborative, autonomous, which I am showing over here, and exoskeleton robots. These are the new generation of the robots, and there is a lot of demand is coming in the industry to use these kind of robots. Collaborative robots directly interact with the human workers without safety fences, are equipped with machine learning capability for easier programming. So their applications are support human work's strength and precision to certain movements. So in factory, you want to, like in automobile factory, it is very common. Automobile factory and assembly line, collaborative robots are very common. And earlier the functions which are being done by the workers, in large number of functions is being done by the robots, and workers just supervise the functioning of these robots. They don't fix those parts. All is being done with the help by the robots themselves. Autonomous guided vehicle is a very powerful technologies. Autonomous guided vehicles and autonomous mobile robots, which the applications of this we can use in logistics and delivery as well as moving pieces such as boxes, pallets and tools. And AGVs are also very commonly used in the drones technologies, which we know. I am not discussing right now that area, drone technology, but AGVs is one of the having a great scope in the defense sector also. Exoskeleton is a robot which are connected to the human body for supporting during heavy duty and ergonomous challenging process steps. So these are the new generation robots which are connected to the human body, human exoskeleton, and those industries which require heavy duty work by the humans, like lifting and etc. These robots are being commonly used in those industries. You are seeing a very interesting picture, a very basic configuration of a robot. I have taken this picture from this site, javadpoint.com. You can see that basically the robot is having these 10 kinds of components, and it is also run under one operating system. Okay, this robot is under Linux, but nowadays robots are having much robust advanced systems which are not simply the Linux OS. So voice recognition, it has certain capabilities. Voice recognition, sometimes temperature monitoring, sometimes temperature monitoring, sometimes the noise monitoring also, sound monitoring or sound listening, etc. To some extent, now robots are able to express the emotions, which we have seen when the robots are working on the reception desk, or robots are working in the hospitals. So there are many kind of robots has come, and this is some basic configuration you can see here. On the left hand side, I have put some of their components like power supply, actuators, and then electric motors, DC, AC motors, depending upon that, whether you are using DC or AC current, sensors. This is very important area of sensors. And we are very lucky that there is a great advancement in the field of sensors, and that's why this robot technology has become so powerful and so useful. And then there is a controller sitting, which is a computer which coordinate the function of this robot. You can see here I have shown a schematic diagram also. So maybe you like to now further explore this picture and like to expand this picture and explore this picture to understand the advanced robots, what all they are doing, what kind of their configuration is there. Cobots, I already discussed about the cobots, and these are some cobots which are the part of the future of manufacturing, All these, my slides are self-explanatory. I have already explained you the basic concepts of the robots, and I'm sure that you will you will make a note of those things, and you will like to take up your own study to further explore this field, upcoming and emerging field of the robots. And what is humanoid, which we will explore in the next session. What is humanoids and how they are helping the mankind in their various areas, and what is the role of humanoids in the smart manufacturing arena also. So friends, this human robot interaction is another some example from the industry, and you can see their physical layer, process layer, and cyber layer, safe human robot interaction, semi-automated assembly plant. So all these examples which I am trying to show over here are from the very relevant sources, and I find that it's a very difficult to explain all functions of the robots. It's a fast emerging area. It's not that the robot is the only recent technology. It is I will say more than 20-25-year-old technology, but the growth and the diversifications in which we are finding in the robot technologies are mind-boggling. This is another setting of the human-robot collaboration, where robot is helping a human for the assembly or deassembly of some equipments. This is another field of physical AI. World Economic Forum and McKinsey are promoting this field of physical AI. Now, instead of discussing the robots, the discussion and the development is going that because today the robot technology is becoming AI replica. I will say that AI is the backbone of the robots. So how AI is, what kind of roles today AI is playing. In this picture you are seeing the three kinds of roles. Rule-based robotics, training-based robotics, and context-based robotics. So rule-based robotics is what AI-supported coding. I will like to cover this area in the next session when we discuss about the humanoids. This is a pictorial diagram of the previous slide only. The rule-based AI you will find like this, training-based robotics like this, and then these are for the taking the X-rays on the move. And context-based robotics is like robots are using taking the role of a policeman for the traffic control. It is something called the context-based robotics. As the context changes, the action changes. This is again, as I said, there is a good development of physical AI. The subject is becoming more organized and structured. I will say the robotic science is becoming more organized and structured. And it is taking the shape of something like physical AI. And this slide I have taken from World Economic Forum study which I have, the URL is being given in the previous slide. You can go through that study completely. So, this is the last slide which I want to make use of over here while explaining the humanoid technology, and we will explore further this concept in the next session. You can see on the left hand side advanced form of the robots which are being used in the industry, and the picture rightly shows that this robot is not only an ordinary robot, in fact, he sometimes the robots, I am using the word like he or she, they also guide that the workers what they should do, that they act as a supervisor in the plant. This you can see that how it is acting as a supervisor in the plant, or how it is, or it is taking direction from the worker, and he will do the task which has been assigned to him. So, this is another scenario, very interesting scenario is emerging in field of industry 4.0, or now it is industry 5.0, and I invite you to explore this area as much as you can possibly. So, what is the area which I have mentioned over here? This is something which I already discussed when I talk about the McKinsey slide. The industrial robots, then these are the traditional robots which which were being used in the assembly line in automobile sector and some other sectors, SCADA sector. The future of the work will depend upon the growth of the robotics. So, this is where the robots play a key role in our industry. So, with this word I like to sum up this session, and hope that you understood the basic concept of robotics and robots, and what I have discussed about the outcome of the discussion. So, thank you very much for your kind attention.